Hello students, today we learn about the geometry of the fabrics and how to actually measure these geometrical properties of the fibers and which the other properties of the fabrics are based on. Pierce, an eminent scientist at the Shirley Institute, generalized the changes in yarn and also fabric form on the basis of geometric similarity, and thus was the first one to establish the fundamental principles of textile structures. The geometry of a textile fabric is determined by the mechanical processing to which the material is subjected from fiber state to finished cloth. The practical geometry of the cloth is described by form factors which are in common use throughout the textile industry. These include yarn count, yarn twist, threads per inch, weave, crimp and fabric weight. So, all these factors can be varied in either warp or weft direction, and the problem of predicting the mechanical behavior of these fabric structures may become complex, as some of the factors which we have just now mentioned may be independent, while others are related either throughout their ranges or merely at their limits. First of all, we will see how to measure the fabric length. So, the length of a fabric can be defined as the distance from one end of the fabric to the other measured parallel to the selvages, while the fabric is under zero tension and free of folds and wrinkles. Length can be measured either by hand method or clock method or folding method. Among these methods, and we see that hand method is the most popular and accurate one. So, as per IS 1954-1990, which is reaffirmed again in 2002, the methodology of measuring the length includes tools like a calibrated steel rule of length at least 2 meters, maybe preferably 3 meters, and which should be graduated in centimeters and millimeters. And then a table having a smooth flat surface of width greater than that of the fabric when prepared for measuring, and of length at least 4 meters. The piece of the fabric to be tested is placed on the table at full width, folded down the middle if received in this state, so that the first 3 to 4 meters portion lies flat and free from applied tension, and then marks are made 3 meters or 2 meters apart near the end of the piece. Then the fabric is drawn gently along the table until the middle portion of the piece lies flat and free from applied tension, and a second pair of markings are made at this stage. And then finally, the remainder of the fabric is drawn gently along the table until the last 3 to 4 meters portion lies flat and free from applied tension, and then again the third pair of markings are made over here. And using a ruler or tape, the fabric length and width are measured accurately, making sure that there is no tension exerted on fabric. Then coming to the fabric width, how we are going to measure this one. In this also, similar to length, we see that each measurement has to be taken to the nearest millimeter and with the steel rule resting on the fabric in a direction at right angles to the selvage. Fabric folded down the middle, if received in that state, may be relaxed and conditioned in that state, but all measurements shall be taken from edge to edge with the fabric open and laid flat. The fabric sample piece has to be placed on the table, maybe at full width or maybe folded down in the middle if it is received in this state, so that the first and second meter portion lies flat and free from applied tension, and a mark is made at a point close to the selvage and approximately 1 meter from the end of the piece. Then the fabric has to be drawn gently along the table until the middle portion of the piece lies flat and free from applied tension, and then a second marking is made over this portion. And then finally, the remainder of the fabric has to be drawn gently along the table until the last first and 2 meter portion lies flat and free from applied tension, and a third mark is being made over here. Using the steel roller, the width of the fabric from selvage to selvage is measured at equal intervals. At least it should be measured at 5 places. The average of these will give the correct width of the fabric. Then let us look at the fabric count, which is a very important geometrical parameter in textile fabrics. In woven fabric, the warp yarns are commonly referred to as ends, and the number of warp threads per inch width of the cloth stated as so many ends per inch. The threads of the weft are called as picks. A fabric may therefore be described in terms of ends and picks. So, this becomes the fabric count. Fabric count or thread count refers to the number of warp and weft threads present in 1 inch of the fabric. Fabric count is an important determinant of the fabric quality. It is accepted that the higher the thread count, the better the technological quality of the fabric. Higher counts require the use of fine yarns, and fewer interlacements in weave structure can also accommodate the inclusion of more number of threads per inch. Breaking strength of a fabric increases with the increase in fabric count, as there are more number of threads, and so the strength that is contributed by these yarns will be higher. But however, tearing strength is decreased just because the threads are available for tearing one by one and not in the form of a group. But comfort is altered as fabric count increases. That is because the spaces that are going to be closed, and so the air permeability decreases, and then the water resistance is increased just because there are no interstices in between, and thus water cannot enter through, and naturally the weight is also increased due to that. And fabric shrinkages decreases with the increase in fabric count because there is no room for shrinking over there, and the flammability also is decreased because it will not be able to support the combustion over there. Fabric aesthetics that are altered include cover, resilience, body, hand and drape. As the cover factor increases with increase in fabric count, resiliency decreases. High thread count fabrics do not generally ravel at the seams, which is an important aspect for ready-made garments. The determination of the number of threads per inch may be made in several ways. One is that it is the use of 1 inch counting glass. This is the most commonly used method. The counting glass is placed on the fabric, and the number of threads per inch are counted through this simple microscope. The threads per inch are counted at different places, and the mean value is calculated. And then there is a second method, that is a traversing thread counter, which is a travelling microscope. It is fitted with a pointer to aid counting. So, at present modern computers with CCD cameras can also be used to count the number of threads accurately by simple modifications in their softwares. And then another method of counting the number of threads is fabric dissection. This is only by dissecting the fabric we will be able to make this particular measurement. So, in this a known width is unravelled and the threads are counted. It is a useful method where the threads are difficult to distinguish, as in case of felted threads or where the structure is very much complex. Example, we have the piled fabrics and all, it is very difficult to see how many threads are present. And then we have another method also by the use of parallel line gratings or taper line gratings. This is a very rapid optical method in which the fine parallel lines are present, and this correspond to the warp and weft threads. It is like a scale with markings of the thread count, maybe 10s, 20s, 30s, 40s, like that it will be present. When it is placed over the fabric, the light rays form a pattern on the scale, and the corresponding thread number is noted in the center. And so, it can be placed on any fabric, even in the bolt, and the reading can be taken easily and more quickly. The regions near the selvage edges should be avoided because the spacing of the thread is often a little different than in the body of the cloth. The 1 inch counting glass is not recommended when the number of threads per inch is less than 25. In such cases, a 3 inch sample could be unravelled and the threads can be counted and it can be taken into for 1 inch. Then a ground glass plate illuminated from below forms a useful surface on which the cloth can be laid when counting threads with a counting glass. It is sometimes convenient to count the number of repeats of the pattern instead of the individual threads. The threads per inch are then obtained by multiplying the number of threads per repeat by the number of repeats, adding on any fraction of a repeat by counting the remaining threads individually. This method is useful when the number of threads per inch is high. In the specification, it will be noted that specimens should be conditioned for at least 24 hours before testing. This must of course be stated in a standard, but in practice the information is often wanted quickly and this refinement is dispensed with. Then we will see how the fabric weight is being measured. Fabric weight is an important parameter while purchasing fabrics for various end uses. The fabric weight is the outcome of how the fabric is woven and finished. The higher the weight of the fabric, the thicker the fabric. Thicker fabric does not always indicate the quality. The weight of a fabric can be described in two ways, either as the weight per unit area or the weight per unit length. Coming to the weight per unit length. The former is self-explanatory, but the latter requires a little explanation because the weight of a unit length of fabric will obviously be affected by its width. To a layman, a 16-ounce worsted does mean very much, but to a person dealing regularly with worsted cloths, the description is sufficient to indicate a certain quality of material. For instance, a 20-ounce worsted suiting would suggest a close weave material which would make an excellent winter suit, whereas a 16-ounce worsted is a lighter material for the warmer weather. In fabric descriptions, the weight per unit length is usually referred to as the weight per running yard. It is necessary therefore to know the agreed standard width upon which the weight per running yard is based, example 56 inches for worsteds. Then coming to the second method of doing it, that is weight per unit area. The method of obtaining this value is implicit in title, that means one has merely to weigh a known area and divide the weight by the area. The actual determination is not so straightforward, since sampling, marking out, cutting, accuracy of weighing and moisture content must all be considered. Area measurement and cutting should be to an accuracy of 1%, and for an area less than 100 inches square, a cutting die or a template is recommended. Weighing should be accurate to 1 part in 500. The effects of moisture content can be accounted for either by conditioning the specimen in a standard atmosphere or by baking the specimen to oven dry weight and adding the official regain of that particular fiber. So, some quadrant balances have one scale graduated in ounces per square yard. A template is used to cut the sample and the square of the fabric is suspended on the hook of the balance. For quick checks, this method is useful and for particular purpose may be considered sufficiently, it is accurate. The modern testing tools today available provide a GSM cutter, which is a template for cutting a fabric specimen, the weight of which is proportional to the grams per square meter. The common term used in industries is GSM rather than the fabric weight. This facilitates easy comparison between the fabrics. It is very important in case of knitted fabrics rather than the woven fabrics. Then coming to the fabric crimp, how we are going to measure it. So, when warp and weft yarns interlace the fabric, they follow a wavy or a corrugated path. Crimp percentage is a measure of this waviness in yarns. Percentage crimp is defined as the mean difference between the straightened thread length and the distance between the ends of the thread while in the cloth expressed as a percentage. From the definition of crimp, two values must be known: the cloth length from which the yarn is removed and the straightened length of the thread. In order to straighten the thread, tension must be applied just sufficient to remove all kinds of kinks without stretching the yarn. In practice, it is seldom possible to remove all the crimp before the yarn itself begins to stretch. The standardized tensions recommended in the BS handbook or so from these two values we can calculate the crimp percentage by using the formula, that is C is equal to crimp is equal to L minus P by P into 100, that will give you the percentage, where L is the stretched length of the thread that is being removed from the fabric and P is the length of the fabric that is present in the sample. So, with this we will be able to easily give the crimp percentage. So, for this 5 groups of threads are selected for tests and 2 are for warp-way and 3 for weft-way groups. The mean crimp percentage is calculated warp-way and weft-way. The rectangular strips are carefully marked on the cloth and each strip is cut into the form of a leg flap. From each strip 10 threads will be removed. To remove the threads, central part of the first thread is separated from the flap fringe by means of a dissecting needle, but the two extreme ends are left secured. One end is then removed and placed in the grip of a tester and the other end is removed and placed in the second grip, which is a movable one. In this way, the thread is transferred from the cloth to the crimp tester without a loss of twist and with a minimum handling. Several crimp testers are available and Shirley crimp tester may be one of them, which is used from the beginning. The second gripper is slowly moved away from the first gripper till the thread straightens. A pre-tension may also be used for indicating the final point. The length of the thread can be read easily from the scale which is placed below. And then coming to the fabric thickness, and fabrics are available with different thicknesses as per the end use of the fabric for which it is intended to. Fabric thickness is associated with insulation and also light absorption. Thick fabrics exhibit high insulation and give protection against UV rays. The principle of measuring thickness is expressed neatly in BS 2544 in 1954. Essentially, the determination of the thickness of a comparable material such as textile fabric consists of a precise measurement of the distance between two plain parallel plates when they are separated by the cloth, a known arbitrary pressure between the plates being applied and mentioned. It is convenient to regard one of the plates as the pressure foot and the other as the anvil. Several points require considerations in the practical application of this principle, and in this shape and size of the pressure foot. So, a circular foot is usually used, a common diameter being 3/8 inch, but this may differ if desired. The ratio of the foot diameter to the cloth thickness should be not less than 5:1. Then shape and size of the anvil. In this, when a circular anvil is used, it should be at least 2 inches in greater diameter than the pressure foot. In addition, where the sample is larger than the anvil, it is convenient to surround the anvil with a suitable support, that is, for example, a smooth plain board. Then pressure being applied. This is preferred pressures are recommended and may be specified. Example, 0 to 1 lb per inch square or 10 lb per inch square, like that. Suitable weight may be added to the pressure foot to obtain these pressures. So, in chapter 10 of the VIRA handbook testing and control, 2 special instruments are described, one for measuring cloth thickness with very small pressures as low as 5 milligrams per centimeter square, and a second which may produce pressures up to 50 pounds per inch square. Velocity of pressure foot is another aspect. The pressure foot should be lowered onto the sample slowly at about 2/1000th inch per second, and precision here is difficult, but of course common sense will suggest a slow and careful movement. Coming to the time, the thickness is read from the dial of the instrument when the easily visible movement of the pointer has stopped. Indication of the thickness is also by a clock. A clock type dial gauge is usually built into a thickness tester, and it should be rigidly mounted in a suitable frame, and after setting to 0 should be capable of measuring to an accuracy of 1% for cloths of 5/1000th inch or more and to 0.00005 inch for thinner fabrics. Coming to the test method, the pressure foot and anvil should be cleaned by drawing some clean paper between them. After cleaning, the gauge is set to 0 and any required weights added to the pressure foot column. No special specimen preparation is required, except that the selvages and creased areas should be avoided. Where possible, the material is tested in a standard atmosphere after conditioning for 24 hours. At least 10 determinations should be made either at different places in the piece or on different samples. The mean value is obtained and reported to the nearest 1/10,000th inch or to 1%, whichever is the greater. In the test report, details of the pressure, size of pressure foot and the time should also be mentioned. So, the information obtained like this, it may be used in various ways. One is for checking the materials against specification, especially in case of felt fabrics and also the knitted fabrics and all. And in the study of other fabric properties such as thermal insulation, resilience, dimensional stability, fabric stiffness, abrasion, all these things, because they are correlated with the fabric thickness, and also in the study of fabric geometry. Thus, today we have seen that the geometric properties of the fabric are very important, and by accurately testing all these geometrical properties, we will be able to predict the properties of the fabric, how it is going to be performing for a particular end use. So, in testing, accuracy have to be followed, and it is always better if you take a sample that is cut to correct measurements, and also it should be conditions in a standard atmosphere.